Hi there, we are looking now at section 5.2, bisectors of a triangle. And we will start with perpendicular bisectors. So I've drawn a triangle over here. We will call it triangle ABC. And I got started by drawing one of the perpendicular bisectors of this triangle. That would be for side AC. Now, I also marked the approximate midpoints of the other two sides. So I'm going to now draw the perpendicular bisectors of the other two sides of this triangle. And if I have any luck at all, this will approximately go through there. And there is our setup. Now, what we have then is three perpendicular bisectors, one for each side of the triangle. And they meet, as you can see, at a point in the triangle, and that point is a point of concurrence, and in this case it is called the circumcenter. And that applies specifically, so this point here is the circumcenter, and it applies specifically to the perpendicular bisectors. This name is only used with perpendicular bisectors. All right. Now the important thing about the circumcenter is that it meets at a point which is equidistant from the three vertices of the triangle. So this blue line is equal in length to this blue line, which is equal in length to this blue line. All right, these three blue lines are equal. This point is equidistant from the three vertices of the triangle. Now, you may have noticed here that the perpendicular bisectors met inside the triangle. That's not always the case. If I drew a right triangle and I made perpendicular bisectors, you would see, let's find the approximate midpoint here, you would see that they are going to meet, remember this is a right triangle here, they are going to meet at a point that is on the hypotenuse of the triangle. So perpendicular bisectors meet at a point on the hypotenuse of a right triangle, and it is still equidistant from the three vertices. So this red line is equal in length to this red line, which is equal in length to this red line. Hopefully those can be seen on the camera. So the distance from here to here, from here to here, and from here to here is the same when you draw the perpendicular bisectors of a right triangle and they meet on the hypotenuse. Now the third one, which I'm going to put, let's see, let's take this one away, and here I'm going to put an obtuse triangle. And in this case, the perpendicular bisectors meet at a point that is outside the triangle. You can see what's happening here. And this, all right, and so that's equal to that in length. This is equal to this, and that's equal to that. So here we have the perpendicular bisectors of an obtuse triangle meet outside the triangle. All right, and just as before, these three, this point, again, it's called the circumcenter, is equidistant from the three vertices. All right? So, in all cases, with perpendicular bisectors, they meet at a point called the circumcenter, and that point is equally distant from the three vertices of the triangle, whether it is inside, on, or outside the triangle. It's inside if the triangle is acute, on the triangle, on the hypotenuse if it's right, and outside the triangle if it's obtuse. All right. Now the other one here, and by the way, I won't be able to do this terribly well, but if I was to draw a circle, and we'll pretend that looks like a circle. If I drew a circle around this, notice that these three blue lines are all radii of the circle. And of course, they have to be equal in length because they are radii. and I could do the same over here, but I'm not even going to try to do that. All right, now let's take a look at angle bisectors. So again, I draw a triangle. We only need one this time, not three. I draw a triangle and I create the angle bisectors. And these are going to intersect, if you'll forgive my drawing here. That's equal to that, that's equal to that, and that is equal to that. And this point is where the angle bisectors meet, and it is called the incenter. And the incenter is equidistant from the three sides of the triangle. So, if I take from this point and draw a perpendicular out to here, not necessarily a bisector, just a perpendicular out to here and a perpendicular over to here, these three are all equal in length because the angle bisectors meet at a point, the incenter, that is equally distant from the three sides of the triangle. This, by the way, if you'll notice, these are always going to meet inside the triangle, because if I drew a different kind of triangle, like an obtuse triangle here, I'm still bisecting the angles, and the angles are inside. So wherever that point is, it's always going to be inside the triangle. Okay, and again, in this case, if I drew a circle inside the triangle, again, forgive my strange looking circle, these three would be the radii of that circle. All